Well, it's not a new thing. Everyone knows that solar system is the best alternative when it comes to electrical power supplies, especially for those that stays in remote area or area that always have blackouts or shortage of electrical supplies. But the thing is that you always see solar system as a very expensive setup to do or something that you cannot afford. But not to worry, that's why I'm here today. Stay with me till the end of this video. I'm going to be sharing with you 3 different ways you can set up solar system within your budget, and it can be in such a way that you can increase the capacity of the installation with time without interrupting the setup. So stay with me to the end of this video. If you are new here, please consider subscribing to help our channel grow. And please, your comments and feedbacks are very important. Make use of the comment section below. Give us your feedback, because TRAQ-Elect is not just a YouTube channel. It's a solution to electrical and electronics problem. So your feedback will go a long way in helping us know the better way to give you better solutions to your problem. Like I mentioned in my previous video, the 2 basic things that determine the cost of solar installation are: 1, the amount of appliances or the rating of the appliances you want to run, and how long you want to run them. So for this video, we are going to be working with 3 different scenarios. The first one is considering all the appliances in your house and decide the ones to power via the solar systems based on your budget. The second scenario is similar to the first, but in this case now, you select the loads you want to power, but then the system will be designed in such a way that if you want to increase the capacity in the future, you can increase it without interrupting the setup of the solar system. Then the last one is just a small budget for someone that wants to power just some few appliances, or a student budget that's just a kind of installation that the student can have, just run few appliances. Okay, let's go into details on these 3 scenarios, how you can actually set up these 3 different types of installations, and then you cut down your budget, or you just stay within the confine of your budget without spending a lot. So let's go to the solar calculator I designed on Excel spreadsheets. I call it my solar calculator. So follow me to this calculator, because we'll be first of all seeing what it takes to install or to run each of these installations, like the first one I mentioned, and then see how we can cut down this cost to our budget. So stay with me. Let's go to the Excel calculator and have our load calculated and know how much capacity our components will be before we decide which of them we'll go with. Okay, this is my Excel solar calculator, and in here I've already designed a way that I can just put the loads or the unit, and then it will automatically calculate the units of systems or components I will need for installation. This is actually the perfect way or fastest way to determine the amount of components or the ratings of components I need for my installations. So starting from the first scenario I mentioned of you having first of all listing the loads you have to power in your house, and then know how much they will cost first. Then you decide the ones you would want to power with your solar or inverter system, and then decide the ones based on your preference that can run on other sources, like your generator or your NEPA light. So from now, my calculator now is divided into 2 parts. The first part is load audit, while the second part is the component specifications. So for the first part, now this is for the first scenario, we have let's say, for instance, it's just a scenario. We have a home that's have a Samsung TV of 200 watts, bulb of 15 watts, and refrigerators, phones, laptops, and this listed. And these are the ratings they have there: 20, 1500 to 300 for the miscellaneous load point. From this energy or load audit, you can see that the total power needed or the total load needed is 2.4 or approximately 2.5 kilowatts loads. That's the appliances you are going to be connected. It's rated in total 2.5 kilowatts of load. And then the energy usage is about 14 kilowatts hour. And then the average time is 5.6 hours. And then here, this other segment is for backups, for adding extra panels to ensure that your solar or your battery charges effectively from the solar panels. So going back to the component specification for these very installations now, first of all, we've listed the load points we want to install, and then going to the component signs. And mind you, these values here are Excel calculated. Like, I use specific formulas to calculate the size of each unit that will be installed. So it's not just a number appearing. There are the basic calculations to cater for the losses of energy due to inverter, and other sources have been put in place. And these are the standard ratings of the appliances that can be used for your installation. So from this now, we can see that for the first scenario, we can see that we will be needing 15 kilowatts hour for batteries, 6 kVA inverter. For total power of panels, we have 5.2 kilowatts hour panels. And we can see from here that the solar, the total energy generated by the panel, that's this one on red, is 21.5 hours 21.5 kilowatt hour, and then the battery is rated 15 kilowatt hour, which means that the panels are enough to charge our battery and still run the system efficiently. So now, based on our budget, we've seen the list of the things we know. So the thing here is that to get the cost of this material, to estimate the cost of this material, well, for now, I'm not going to give the cost of the materials because they are not guaranteed. Though I can suggest an estimate. Let's take, for instance, that this is a 15 kilowatt hour. If we are using lithium battery, costs like let's say 4 million naira, which it can actually be. Then for the inverter, it can cost, let's say, around 2 or 1 point something, or around yeah, let's say 1.2 million. Then for the panels, we can get all for about around 800,000 or so, depending. Now, for instance, for these panels, now if we have 5,200 watts of panels, calculating the rating now, that if you're using like 300 watts panels for this, so we can use a 5200 divide by 300. So we can be needing that's about 17 pieces of panels to run these systems, and then each of these panels can cost about let's say at average 80,000. Multiplied by 80,000, about 1.3 million naira also for this size of, or for these panels. And then now calculating your budget, now you see that what it takes to run your entire house or your entire system, it's outrageous compared to the budget you have. So you can decide to cut down some of the appliances and then connect those that your budget can afford, and then have the other appliances run on other systems or other energy sources like your generator or your other national electrical supply. So to reduce this load point, you can decide that, okay, the refrigerator can run on other sources. So we'll remove refrigerator. So we'll just delete everything that have to do with refrigerator. We'll cancel refrigerator. There is no fridge. Also, the extra backup for the refrigerator removed. And then what else can we remove now? We can decide that, okay, we cannot connect 6 sockets to these installations. We reduce the amount of sockets we plug to this. Reduce it to, let's say, just 3 sockets be connected to this system. And then among the 3 sockets, no socket should rate more than, let's say, 80 watts. So this is just a way to reduce your loading, the loads in your house. And then for miscellaneous, now we might choose that, okay, there is no miscellaneous load that should worth more than 100 watts. So by this, you will cut down a lot of expenses on installations. So going back to our components required, we can see that the size of battery has reduced to 9 kilowatt hour battery, which we can use a 10 kilowatt hour for these installations. And then our inverter system has also reduced to 4 kilowatt hour. And then panels, we can comfortably use 3.3 kilowatt hour panels for this installation. And so our charge controller as well, if it's an installation that we can use an external charge controller, but most inverters, that's for Felicity inverters, most of them come with inbuilt MPPT charge controller that will be enough for maximizing or maintaining the charging of the systems. So if this budget is, or if this analysis is still not enough for your installation, you can still choose to reduce some appliances again to suit your installations. Let's say, for instance, now some of the bulbs are not going to run on solar systems. I reduce the bulb. Let's say instead of 10 bulbs I have, I can say that, okay, this unit of bulb, like let's say only 8 units of this bulb will run on this solar. And then for phone charging, only 5 phones can be plugged at a time or in a day. And then for miscellaneous, I can even choose to remove miscellaneous. That means there is no other load point that is not determined from this point will be plugged to the system, and then the system will be designed in such a way that this principle will be followed to ensure that the usage or the outcome is fully maximized, and the system is fully optimized for maximum performance. So this is the first scenario, and this is where you can go about not going beyond your budget of installation. So during installations, you can let your professionals know your preference so that they make budgets based on how or what you can afford in your homes. For the calculations, actually, there are Excel calculations, and there are standard considerations that are put in place to ensure that the losses in terms of a battery and the inverter systems are put in place. For instance, ideally in this system, you can see that the load rating here is 1.6 kilowatt. You can actually use a 1.6 1.6 kilowatt hour or kVA inverter, but comfortably for surge and all of that, you can choose to run with 3 kVA inverter so that you can run comfortably. Then for the second scenario, which I say it's similar to the first scenario, is that you can choose to install this system, see everything being the same. This system can be in such a way that though this load be separated, but then they can be in such a way that when you decide to increase your load, you can as well increase the capacity of the system without changing the setup. So in doing this now, your installers or your professionals have to, you have to like make them be aware of your plan to increase the capacity, so that they will choose materials or they will choose the type of installations that the capacity can be increased with time without altering the setup, because altering the setup of an installation in the long run might cost you spending more than expected. Yes, because it might result to replacing an entire component because the system it's no longer going to be the way it was. But then if you consider this from the beginning, which is the second one, the second scenario, whereby you have it in mind in the future that you are going to increase your capacity of installation. So for instance, now this battery now, it can be in such a way that, you know, instead of using 10 kVA battery, which this installation demands now, you can choose you can choose to use double 5 kilowatt hour battery, so that the next time you want to add the battery, you can implement it or increase it by 5 kilowatt hour battery. Same with inverters and other systems. So, and it's actually advisable to use, like here, to use a higher inverter system, so that whenever you choose to increase the load, you don't have to replace the already installed one to meet up with your daily energy use. So for the last one, which is a very low budget that you can choose, just low budget components to use for installation, and this budget can also be suitable for students that just have few appliances to power. You don't need to connect much load to this system, just few appliances to run with. So this budget can actually be very low, and you can get low solar appliances. So let's estimate what this load can look like. So for this type of load, you don't need a television. So the column for televisions be removed. So then you don't need a refrigerator. So refrigerator be removed. You don't necessarily need your laptop. A single laptop is okay of 80 watts. Then for ceiling fan, you will just have a single ceiling fan. And that means if you're having ceiling fan, there is no need for a standing fan. So for this standing fan, we can just remove everything about standing fan. So there is no standing fan. And then for sockets, we can just choose to run with just a single socket, or preferably no sockets. So that's 0 for that. So we're not using any socket for this installation. Then for our miscellaneous, we can choose the miscellaneous can just be a single miscellaneous of not more than 100 watt hour. So let's check out the size of, or we can just choose to cancel miscellaneous, because this is a very low budget installation. So there is no miscellaneous here. So let's check out this size of installation, which can also be suitable for students. For our bulbs now, we can, how many bulbs do you need? Just like 4 bulbs of 15 watts each. So with this budget, we can see for our total load demand, we have just 360 watts of load, and then our average running time is about 4 hours, which we can, which our average running time is about 4 hours, with the maximum running time of 8 hours, which is for our bulbs. And then for the total energy demand, or total energy in watt hour or in kilowatt hour, it's 1.6 kilowatt hour that we are required to generate. And then this is our extra time. We giving it an extra time of 3 hours. So we can decide to use extra time of, let's say, 2 hours, because we want to cut down this expensive or the budget as little as we can. And trust me, this budget or this analysis have been carefully selected, and I'm sure this will meet any kind of setup with this kind of load systems. So for the, let's go to the components now. The components, you can see that with 1.8 kilowatt hour battery, we can run this. So for this installation, 1.8 kilowatt battery, if we're using a 12-volt battery, let's do the math. That's about 1,840 watt hour. Divide by 12. That is, if we are using 12 hours battery, divide by 12, we will have 153 amp hour. So we can comfortably use 150 amp hour battery or 200 amp hour battery, 12 volt 200 amp hour battery for this installation. And you know that this budget is as low as it can. Let's say we can choose an Eastman battery, an Eastman battery of this capacity, 200 watts hour, and then which costs about, let's say, around 200,000. And then inverter, this size of inverter can cost, which is about 1 kilowatt hour or 1,000 watts inverter. It's not more than a 50 or 60,000 naira. And then your PV panels, with this now you can see that our panel is rated that's around approximately 600 watts panel, which we can just use double panel of 300 watts to meet this demand. And you can see that our charge controller, because definitely this one we're going to be using a charge controller, because this size of inverter does not come with an inbuilt charge controller. So can be using a 13 within a charge controller of within 13 to 20 amp maximum current. So with this now, our budget can be as low as, like, we can actually run this installation as at when this video is made at not less than 500,000. So 400,000 or 500,000 can comfortably run this installation for you. And then definitely, if it costs less to run this than going for, let's say, 1 kVA generator, which you will spend much on fueling and all of that, and you live comfortably as a single home user or a student. So that is it. Thank you very much. So whatever way you choose, or whichever method you choose, any of these can actually help you stay within your budget of installation without spending too much. So solar electricity supply is actually cheap. It depends on your budget, and then you can make it as budget friendly as you can. Thank you.